All right, my friends, let's go through it. So we've got a sub 1 is equal to sine of pi over 2 times 1, which would just be sine of pi over 2, which I believe is 1. A sub 2 would be sine of pi over 2 times 2, which would be pi, which would be 0. A sub 3 would be sine of 3 pi over 2, which would be negative 1. A sub 4 would be sine of 2 pi, which would be back to 0 again. And so without showing the work, I hope it makes sense that if you were to like maybe list the terms in order. So let's see. Let's see, you go 1, 0, negative 1, 0, and then the pattern would repeat itself. So 1, 0, negative 1, 0. So those are the terms of the sequence. And so would we say that the limit as the number of terms approaches infinity of this rule, sine of pi over 2, and would we, pi over 2 times n, sorry. Pi over 2 times n. Would we say that that equals a distinct finite value? And so I hope it makes sense. The answer is no, because it keeps oscillating. So the limit value would not exist. So we would just say this limit does not exist. And so because it does not equal a distinct finite value, we would say that in this case, the sequence diverges. So A sub n diverges. There we go. And if somebody says, well, what does it diverge to? We wouldn't be able to really say, right? Because it just oscillates between, 1, 0, and negative 1. There you go. Okay. All right. And then for part B, though, the rule, A sub 1 would be 1 over 1 times sine of pi over 2 times 1, or just sine of pi over 2. And so we'd end up with 1. A sub 2 would be 1 over 2 times sine of pi over 2 times 2, which would just be pi, which would be 0. What would A sub 3 be? Well, it would just be a third of what we would have gotten over here for part A. So it would be negative 1/3. A sub 4 would be 0. A sub 5 would be, 1/5, right? Okay. So you could visualize this in a couple ways. Like some people really like the list method. Some people really like the list method. Some people like to visualize these graphically. And so what I'm going to do real quick is just show the two graphs. So for part A, what's the visual here? So if you were to start plotting, if you have an n-axis, right, and a value of the term axis, so you got 1, 2, 3, 4, 5, etc. Then what did the terms look like, right? So they looked like this. And they would just kind of continue that way. But for B, it's a pretty different story. For B, first term is 1. Second term is 0. Third term is negative 1/3, which would maybe be about here. Fourth term is 0. Fifth term is 1/5. Sixth term is 0. Seventh term, negative 1/7. Eighth term, 0. And then ninth term would be 1/9, etc. And so, so in this case, if you really look at the value of the terms, what does it look like the value will approach as you get higher and higher in the list, as you go farther down the list or farther down the graph? And so in this case, I would say for part B that the sequence converges to 0, whereas for part A, the sequence diverged. Hopefully that makes sense. So we would say that for part B anyway, let me divide this out. We would say that A sub n converges to 0. And remember, a way to figure that out is to just let n go to infinity on the way that the terms are defined. And so I'm just going to take that. Oopsie, make sure that you're good with some moves here. So 1 over n times sine of pi over 2n. And then to kind of explain that this is 0 without having to do the list or the graph, you could do a little bit of fun work here. Limit as n goes to infinity of sine of pi over 2 times n over n. And then you could really, honestly, you could use a squeeze theorem thinking. So the number on the top is always between -1 and 1. So I could say sine of pi over 2 n is always between -1 and 1. And then but you're dividing it by this number that's going up to infinity. And so that's kind of a squeeze theorem argument. Anyway, so you have this number that's fairly small in magnitude divided by something that's getting, completely unlimited in magnitude. And so your value would get squished to 0. Oops, I almost wrote infinity. Anyway, there you go. So that would be a way to conclude that the sequence converges to 0. There you go. Okay, let's see. For example 3, I just want to make sure that you would know what to do if math yells at you. No, just kidding. See if you can remember how to deal with factorial, and then I'll go through these with you in the next video.